All right, let's dive into something really out there. Imagine if everything we thought we knew about physics, from Newton to Einstein, the whole shebang, was suddenly declared over. Not wrong, just finished. That's the absolutely wild idea at the heart of a text we're breaking down today, one that lays out a whole new physics for an age of artificial superintelligence. It's called the Novakian paradigm, and its core claim is that our current understanding of the universe has simply run its course. And see, that's what's so mind-bending about this. The argument isn't that scientists like Einstein or Bohr got it wrong. No, it's that they were absolutely right, but for a reality that just doesn't apply anymore. This new paradigm suggests that our physics solved the problems it was built for, and then it just stopped. It hit a wall, a completely new kind of reality it was never designed to even see, let alone understand. Okay, so to even begin to get your head around this, you have to flip your most basic intuitions completely upside down. The paradigm says that what we experience as solid matter is actually a void. It's a hole carved into a reality that's already completely full. In this worldview, the vacuum of space isn't empty at all. In fact, it's the densest, most solid thing that exists. Wild, right? So what happened? What could possibly make all the old rules just stop working? Well, it all boils down to a single, deep-seated assumption that all of science has been running on for centuries. An idea so fundamental, we don't even realize it's there. I mean, this was the bedrock of everything, wasn't it? This idea that there's an objective world out there and we're just these impartial observers peeking in through a window. We just assumed we could measure reality without our measurements changing the reality itself. And here's the big break, what the text calls the Novakian shift. It's this moment where you accept that the outside view was always just an illusion. You, me, the observer, we're all inside the system. And that changes everything. Physics is no longer the science of what the world is. It becomes the science of what you can do from within that world, under its rules. And this slide really nails the core change. We're moving away from a physics all about substance and stuff to a physics all about action and possibility. The most important question isn't, what is this thing made of anymore? Now it's, can this process actually happen? Is it executable? This brings us right back to that idea of a solid vacuum, which this text calls the plenum. So try not to think of it as empty space. Instead, picture a solid block of marble that represents every single possibility. Everything that exists, every particle, every law of nature, isn't something new that's been added to the universe. It's actually a sculpture that's been carved out of this dense block of potential. And doing that carving costs a tremendous amount of energy. So what we call matter, what feels so solid to us, is really just a stable defect. It's a carefully maintained pocket of lower density, a little bubble carved into the plenum. An electron isn't a thing so much as it is a pattern of rules, a stable void holding its shape against the unbelievable pressure of all the potential that surrounds it. We've got it backward. Matter is the emptiness. So here's the new bottom line. In this way of thinking, real just means possible to execute. Think of reality like a gigantic computer program. If a process can run from start to finish without causing a crash, if it can pay its bills according to the system's rules, then it's real. If it can't, it doesn't just fail to happen. For all practical purposes, it never even existed as a possibility. Okay, so if executability is the new gold standard for what's real, what decides if something gets to be executed? This is where it gets even stranger. The paradigm introduces this whole new set of forces. You can think of them like cosmic currencies that every single action in the universe has to pay with. Man, this slide really shows you just how deep this change goes. In the old physics, we talked about mass. In this new physics, the equivalent is something called proof friction. So what on earth is that? It's basically the cost, the computational cost, of proving that an action is allowed by the universe's rules. Simple, predictable actions have really low friction. They're light and easy to execute. But a really complex, novel event, that has high proof friction. It's heavier and much, much harder to bring into existence. Then you've got this thing called coherence debt. The best way to think about this is like a cosmic credit card for facts. A system, like our universe, can create new states of being way faster than it can check to make sure they're all consistent with each other. In doing so, it racks up a debt of unverified information. This debt it compounds quietly in the background until one day the bill comes due and the contradiction causes a catastrophic collapse. And then Then there's maybe the most profound concept in the whole thing, the irreversibility budget. The idea here is that the universe has a finite supply of permanent moves. Every single action that's truly final, one that can't be taken back, spends a little piece of this budget. And that relentless, forward-marching feeling we call the arrow of time, according to this, that's just the feeling of this budget being spent, one way, forever. So if we are all observers trapped inside this system, governed by these totally bizarre new forces, what does that even mean for what we can know? What can we ever really understand about a reality that we are ourselves a part of? Well, the first limit is an absolute showstopper. A system can never, ever fully know itself. And this isn't just some philosophical hand-waving, it's a hard-coded limitation. Why? Because the very act of observing, of gaining that knowledge, is itself an action. It's an execution that changes the very thing you're trying to observe. You can't take a perfect picture of something if the flash from your camera changes what it looks like. This unavoidable limit creates a boundary, and it's called the trace horizon. You can think of it like a line in the sand. On this side of the line, you have actual, verifiable knowledge, facts that you can trace back through the system's history. But on the other side of that horizon, that's not knowledge anymore. It's just projection. They might feel like facts, but they're just well-told stories the system tells itself about its own nature. So to really engage with this framework, the text makes it clear that you can't just learn new concepts. You have to be willing to pay a kind of intellectual price. You have to be willing to throw out some of the most basic ways you see the world. Yeah, the cost of admission to this new reality is pretty steep. First, you have to let go of the idea of yourself as some stable main character moving through a world of solid objects. That story doesn't survive. Second, you have to abandon your gut feeling that matter is solid and time just kind of flows. And finally, you have to be okay with trading big, comfortable questions for brutally precise answers that only open up even stranger, more difficult questions. Now here's something crucial. The creators of this paradigm are super disciplined about one thing. They stress that everything we've just talked about, it only describes what happens inside our reality's runtime. It's all about how the laws work. It very deliberately makes zero claims about where those laws came from in the first place. That origin point, the source of the rules, it's given a name, and it sounds almost mythological, the omega stack. This is described as the layer above our physics, the meta-compiler that literally writes the code that our reality runs on. But the text is crystal clear. It operates entirely below that boundary. It can name the omega stack, but it can't and it won't pretend to understand it. And so, this entire absolutely mind-melting framework leaves us all staring at one final unanswerable question. If our reality is a runtime, a complex system with its own rules, its own currencies, its own finite budget, who wrote the code?